Conceptual Geometry, Unit 9, Day 1, Circle Terms and Central Angles. So let's begin with parts of a circle. The first one is a radius, and we don't need to write this out, but we just need to sketch it in. The radius is a segment that goes from the center of a circle to a point on the circle. A diameter is a segment that goes from one point on the circle to another, but also through the center. And there's a relationship between the radius and the diameter. We can write that underneath here. The diameter equals 2 times the radius. So it's very easy to calculate one given the other. If I give you a radius, you multiply it by 2, there's your diameter. If I give you a diameter, you divide it by 2, there's your radius. The next one is a chord, and a chord is simply any segment that goes from one point on the circle to another. It doesn't have to go through the center. So there's an example of a chord, C-H-O-R-D. A secant line is a line that goes through the circle. So if you notice a chord is a segment, a secant is a line that goes through. It continues through the circle. Next we have tangent line. A tangent line or a tangent, it's a little bit different than we talked about in right triangle trig. This means it touches the circle exactly one time. So it's just resting on the surface of the circle. And the point of tangency is the point where it touches the circle, and there's only one. If there's 2 points, then it becomes a secant because it's actually going through the circle. Concentric circles, like a bullseye, are circles that have the same center. So we can draw a bunch of these concentric circles. We don't deal with those a whole lot, but it's kind of good to know that term. And then we have congruent circles. Remember in geometry that word congruent means equal. So we basically have 2 circles that have the same radius or same diameter. So whatever the radius of one circle is, the other circle is going to have the same if it's congruent or equal. Now the next group, the next 2 I should say, are super important. We deal with these 2 for the majority of what we talk about in this unit. The first one's called a central angle. Now, as the name implies, central, center, this is an angle formed by 2 radii. So I'll draw the angle in right there. Its vertex is the center of the circle. And there's a very important relationship between the central angle and its arc, which we'll talk about in a little bit. And then an inscribed angle looks similar, but in an inscribed angle, it's an angle formed by 2 chords. So its vertex is on the circle. So notice the difference between those 2. Very important we understand and we can identify the difference between a central angle and an inscribed angle. Next, we have an inscribed polygon. This could be any number of sides. Inscribed means inside. So let's do a 5-sided inscribed polygon. It's actually pretty easy to draw. Random point on the circle. You can make as many sides as you want. I'll just make it a pentagon with 5. And then just connect them. It's like connect the dots. There's an inscribed polygon because it's inside. The next one's a little bit harder to draw. A circumscribed polygon means the polygon is on the outside. like to circumnavigate the globe, you have to sail around the whole outside of the globe. So circumscribed polygons on the outside. I find it easier to draw a triangle in this case. So I draw a tangent line going across the top, then draw a tangent line coming down here, and then you have to draw a tangent line to connect those. It's a little bit harder to draw. So there's a circumscribed polygon. The more sides you add, the harder it is to do that. This one is hard. Inside is easy. Outside is hard. We're not going to deal with those a whole lot, so not a biggie. But these next two, we will. Minor arc, major arc. So what I'd like you to do here on this circle is pick 2 points, A and B. The minor arc is the closest distance between those two. So it has to be less than 180 degrees. So a minor arc, I could name AB and put an arc symbol over it. A major arc has to be the longest one. So I'd have to go this direction here. That's a major arc. Now to name a major arc, you need a third letter. So I couldn't name this arc AB. I'd have to put some random letter over here. I'll make it a C. And now when I name it, you have to name it in the order you travel. So arc ACB would indicate a major arc. The next one's pretty easy. It's a semicircle. I'm sure you guys are pretty familiar with a semicircle. Simply means it's half a circle. So you can pick any diameter and then go around one way. And a semicircle, we should know, is equal to 180 degrees. In example 1, we are going to use all the vocab from the previous page, take a look at this diagram, and then list some parts. And pay attention to the symbols we use, because like I said, they represent the actual shape. Part A, you want 2 radii. I see 3 of them. Doesn't really matter what order you name them. A radius has to contain the center, so every one has to have an O in it. OE is a radius. OT is a radius. OD is a radius. And again, you could name those in reverse. Same thing. A tangent. 2 tangents. A tangent is a line or a segment that touches the circle only one time. So it has to rest right on the circle. I see 3 of them. One of them is XY. YP is another one. I only have to name 2, so I'll stop there. But you could also say XP or PX. That's another tangent. A secant is a line that goes all the way through the circle and comes out the other side. So I only see one secant, and that would be CP. A diameter, I only see one, DE. Has to go from one side of the circle to the other and through the center. 3 chords. So if you remember what a chord is, it goes from one point on the circle to another point on the circle. It doesn't have to go through the center. It can. A diameter is a chord, so you could name that again. But I'll pick some that aren't. FE is one. FD is another one. And so is DT. But like I said, you could say ED. That's a chord. A diameter is a chord. A central angle, I see a few of them here. Probably the easiest one would be angle DOT. Remember, a central angle has to be in the center of the circle. So there's a picture of a central angle. Next, an inscribed angle. Well, an inscribed angle has to go to the edge of the circle. So there's an example of an inscribed angle. Angle EDF. A minor arc, there's lots of minor arcs. We just need to pick one. I'll pick a random one here. Show you on the diagram, that's FE. So all you have to do for that is put the two letters with an arc symbol over it. And now major arc, I'll use those same two letters in a major arc, but I have to go the long way around. So I need an F and an E, but then any letter in between. So let's say F, D, E with an arc symbol over it. That would indicate that yellow major arc. A semicircle is half a circle. I like to identify the diameter, and I just go one way or the other. ED, DE, it doesn't matter. And put an arc symbol over it. Next one, inscribed polygon. I'll pick a triangle. Triangle FDE is inscribed, it's inside. Circumscribed polygon, that'll be the big one on the outside, also a triangle. Triangle XYP. A point of tangency is any of the 3 points where the tangents intersect the circle. A is the first one I notice. An isosceles triangle, this one's interesting. We'll get to this in a bit. An isosceles triangle is a triangle formed by 2 radii because all radii of a circle are equal. So triangle DOT. All right, the last part of today's lesson is defining a central angle. And a central angle is an angle formed by 2 radii. And this is the easy part. The degree measure of a central angle is equal to its intercepted arc. So knowing that the central angle is equal to the arc, we can calculate some of these values very quickly. In the first one, find the value of x. It's a central angle. The central angle is equal to the arc, so those two are equal. It's that fast. X is 85 degrees. The next diagram. Oh, here's my central angle. It's equal to the arc. X equals 110 degrees. Piece of cake. I'm going to skip around here to the easy ones and then do the hard ones. Next, let's take a look at the 45-degree angle in this circle. That's a central angle. It's equal to the arc. X equals 45 degrees. Now, the next 3 are a little bit more challenging. Here's why. Let's go back up to the top. Here's x, but here's its arc. I don't know the arc, but I do know this one. So all we have to remember here is that to find the minor arc, if I know the major arc, you just subtract it from 90, that's 70. That means that arc is 70, x is 70. So the last 2 examples, similar concept. In this circle, I'm looking for this arc, which is x. But I know this central angle, which is 120. So the central angle is equal to the arc. This arc over here in green is 120. Combined, I know the green arc and the blue arc have to add up to 360. So to get x, you just take 360 minus 120, 240. And then a similar concept for our last example. I know the major arc here is 280. I know x is equal to the arc, so this minor arc here is x, and together those two have to add up to 360, so x is simply 360 minus 280, which is 80 degrees. And that concludes lesson 1.